Any questions? Excuse me?
Is it like in questions in general or like about whatever we're gonna do?
I figured they'd be physics-related questions, but that isn't always the case.
Yeah. I was just wondering if we could do a problem like we did yesterday because I got lost right after the first S.
Ah, okay. So you need me to go through the facades method? Okay, we will. Yeah, we will. And that's not just a threat, it's a promise. Any other questions besides what I was planning to do anyway? Alright, so it was the math piece of it that messed you up, not the physics.
I guess like starting from the equations all the way down to the bottom. Cause I get how you got the equations part,
Right,
but when you went to like substituting and all that, I just completely lost it.
okay.
Like, I guess basically the two S's at the end.
Okay, I was trying to decide if I needed to do a problem similar to yesterday in the setup, or just if I could do box on ramp.
Yeah.
So I'm gonna do box on ramp, and if it still doesn't satisfy the need, then we'll go from there.
If we can keep the box on sequence.
Start straight. Like Carlos Castaneda novels. Repeat the same story, just tell it slightly differently. Hopefully with fewer drugs than Carlos Castaneda. I guess we'll stick some numbers in here. Let's make that 5 kilograms. Make this 37 degrees. Use of S is 0.3. Use of K is 0.25. What else do we need? Okay.
Can you explain, so when you sub S, all that means is, friction when static?
Yes, when not moving, when not sliding. The two objects are not moving relative to each other.
That's what their friction is, and then mu sub K is, friction when two objects, or when the objects are moving with respect to each other.
Right, when there's sliding going on. I would amend, it's not the friction, it's the coefficient of friction.
Coefficient.
Yeah, these are unitless, these are not forces in of themselves. It is a measure of the two surfaces involved. Well,
Yes. I did not.
all right, so what's the first step?
Force diagram.
All right. Now, before, when we were doing force diagrams, specifically, we did the forces on the ramp. Also, we can still do that, but the mass is the only one that really is of any importance here. So I guess the problem is the acceleration of the mass is what? So what are the forces acting on the mass? We have our second checklist.
The grid where you
All right.
go. Okay, so we have.
Going which way? What's opposing that?
Oh, that's. Just force the ground, right? Because it's supposed to.
There is a force, if I did the ramp here, there is a force going that way. Is that the one you're talking about? Ah, okay. Yeah, I wasn't doing, both forces in the pair, but we can.
There's friction going, I wanna say up the ramp.
Yeah, up the ramp's fine. And then down the ramp there. All right, so we've taken care of normal and gravitational.
No,
Normal.
Oh,
Gravitational.
okay.
Down.
And now gravitational, I was just ahead of my time, and no other intention. Sorry, spoiler for those who wanted to say that. All right, so we've done the force diagram. Oh, I guess for completeness, there's a way backing out there. All right. Whoa. If it accelerates, which way will it accelerate?
this way, I guess down, and pull.
Okay, I'm fine with down the ramp, just the word down by itself. The hand gesture also worked. Down is that way, and it's not gonna accelerate down, because this mass right here, the ramp, is part of the ground. Thus, I didn't have a line here. If it were not part of the ground, then as this went down, it's actually not gonna accelerate that way, but it will accelerate something like that, because this potentially is going to get squeezed this way. So acceleration, if it exists, will be in that direction. And again, it's not part of the force diagram, it's just a separate note. Do not stick acceleration attached to this mass here as if it's another force. Acceleration, done. What is CA?
Coordinate axes.
In which direction should we make our, how should we set up our coordinate system?
Down is positive, to the right is positive.
Like that?
Yes, sir.
I would not recommend it.
Up is positive.
I know, that's not the issue there. If, watch the video if you haven't yet. And maybe you just enjoy the math, and you wanna to solve, 3 equations, 3 unknowns.
Oh, well, never mind.
You could do, I don't know if this is right, but you could make the direction of acceleration the x-axis and then perpendicular to it the y-axis?
Yeah, that's the recommendation. Make one of the axes in the direction of acceleration. Make one of them perpendicular to that. So I'm gonna set up, and apparently I have only 2 colors that I work with here. There we go. So we're gonna make down the ramp, I'm gonna do I hat. And then the other one perpendicular to it, whether it's away from the ramp or towards the ramp, it really does not matter. Carolyn, since you were suggesting this,
That way.
and some textbooks will stick with calling this the x-axis of x hat and y hat. I tend not to, just because of the brainwashing from the math people of x being horizontal and y being vertical. Because then you end up with responses like we saw or heard earlier.
Awesome sauce.
You need to break away from the math. The math people, great people, but they brainwash you.
So I get to pick whether.
Deprogramming 101. All right, so coordinate axes, done. Now the question for decomposition, we didn't have to do that last time, but the question for decomposition is, when I look at the 3 forces that are acting on the mass, are any of them not parallel, anti-parallel, or perpendicular to my axes?
They're all, perpendicular.
The weight.
Yeah, you're right, they're right.
Okay, I was wrong. Yes. Normal force in the J hat, friction in the negative I hat, weight it's not in one of those, so that's the one we need to break up. So we decompose any of the ones that are not along those lines. So we're breaking it up. So I'm just gonna set up a triangle here. That angle's theta. Weight is acting down. Whenever I am breaking up, that is the hypotenuse of my triangle. I know one of my axes is down the ramp, one of my axes is into the ramp. So basically I'm creating a right triangle with my hypotenuse is that which I want to break up. Now, if we had chosen if we had chosen vertical and horizontal as our axes, we would have been breaking up two vectors here. Plus there's additional math later on. So the question is, one of these will be the weight times the sine of theta, and the other one's going to be weight times the cosine of theta. Which one's which? Well, we can work through it several different ways. First off, if in the larger triangle here, that's also a right triangle. If this is theta, what is this angle up here?
Theta, no. No, wait, my brain, hold on. I was thinking that the angle, down in the corner,
This one or this one?
that one.
This
The
one?
one where that one would be theta.
Okay. Why do you think that one's theta?
Because like, my brain's telling me, if I was to take that triangle outside of this triangle, and then just move it around, it will, and position it the same way, where the right angle is on the same side, then it would be theta on that side, or on
Alright.
that corner.
And that's another way of doing it. It wasn't one of the ways I was going to suggest, but yeah, no, that is theta there. For those of you who did not see that or follow it, basically he took, imagine you take the green triangle and then you reorient it so that it matches this right here where you still have the right angle. So you're moving that right angle to here, that flips down to here. I don't know if I said it better than what you did, but visualizing it could work. A different way. What is this? So let's forget about that for right now. Thinking about the green triangle here, this green right triangle. What is this angle?
I could be totally wrong, but 45 degrees.
No, not 45.
I said that because the black triangle is a 90-degree angle, it'd just be 45 and 45.
53, if I'm doing math right.
Throw some units in there and spot on.
Degrees.
Yeah, if that's 37, this would be 53 degrees. In general, this is the complement. So those two angles have to add up to 90 degrees. Now, the way I represent the complement in terms of notation here is I'm just going to label this as theta prime. It's for the formality of it, theta plus theta prime is equal to 90 degrees. So now looking at the black triangle, if this is theta prime, this angle would be, yeah, as earlier discussed. A third way, because it really depends on how's the brain working at the moment, you need to figure it out. Now when I draw my triangles, this one less than usual, but a lot of my triangles look like 45, 45, 90-degree triangles. And so it's very difficult just on visual inspection to figure out which one it is. If I draw it more extremely, I know that this is under 45 degrees, so I'm going to draw a triangle with an angle under 45 degrees. I think that's clearly under 45 degrees there. I've got weight acting down. I'm going to break it up into a right triangle here. So clearly when I've drawn it this way, I've got my two sides here. One is clearly bigger than the other one. That's bigger than that one. Well, One of them is gonna be the weight times the cosine of theta, the other one's gonna be the weight times the sine of theta. So you plug them both into your calculators. The smaller value is this one, the larger value is that one.
So the smaller value is cosine, the larger value is sine.
No.
No.
For 37 degrees,
Oh, wait, no. The,
cosine of 37 is about 0.8, sine of 37 is about 0.6. So ultimately, it's gonna come down to looking at the black triangle here. This is the opposite side to that angle theta. So this is W sine of theta and W cosine of theta. So one of the shortcuts I will take at some point is, usually there's some question again at some point, and I'll be glad to go over this again. But one of the shortcuts is if I'm given that angle down there from the horizontal, this is gonna be the sine, that's gonna be the cosine.
always?
What's that? I heard O.
No, always.
Yeah, if you're given that angle, then yes.
So if it was like 43 degrees, that would still be sine, that would still be cosine,
Yep.
as long as it's on, okay.
Yeah. And if you're given, if it's more than 45-degree angle, and I'm breaking weight up, weight's acting straight down, I break it up into a right triangle. So if theta is more than 45 degrees, sine is bigger than cosine, and the opposite is the larger one. Questions to hear before we get back to, I'm gonna modify my force diagram now that we've decomposed. Added nutrients back to the soil. All right, so what I'm claiming now is that if I look at my mass, I have normal force going this way, I have friction going this way, and my weight I can break up into W cosine theta into the ramp, W sine theta down the ramp. I'm claiming that this and this are the same thing. Because if I add these two together, I'm gonna get W. Hopefully you recognize when I say add them, I'm adding them like vectors because they are vectors.
So would it be right to add a vector sign on top of the W?
No, because I'm indicating direction by the arrow here. This W sine theta is the magnitude of the vector that is down the ramp. All right, decomposition. Done. And Skylar, you okay with the equations of motion, or it's the step after that, right? You said the two S's?
Yeah.
Okay. How many equations of motion will we have?
Two.
Yes. Why two?
I don't think we have enough components to have three. And I think we have more than enough to have one.
Okay, and we have a more specific reason?
You only have one mass.
Excuse me?
Is it because you only have one mass,
And?
one acceleration?
There's two.
The number of accelerations is not the key thing.
There's two axes.
Yes, one mass and two axes. All right, so I have two equations of motion. I'll have an I hat equation, and I'll have a J hat equation. Who wants, preferably someone who doesn't speak a whole lot, who wants to be bold enough to try to tell me what the equations of motion are? make mistakes.
I just have a question. Just making sure. So just making sure, equations is all based off of that force formula, right?
F equals ma. Absolutely, yes. These are not the equations from chapters 2 and 3.
Would the I hat formula be W sine theta minus friction? Equals mass times acceleration.
Yep.
How did you get that?
Justin told me.
Just let you get it.
You take the positive force, in the direction of the I hat, which in this case would be the W sine theta, minus the opposite direction of force, which is friction.
So,
Equals mass times acceleration. In that direction.
then the second one for J hat would be the normal force minus the, would be friction? Or is it-
Is friction in the negative J hat direction?
No, it would be, the other normal force.
The other normal force.
The one that you wrote acting on the.
We're doing the diagrams that are for the forces, sorry, doing the equations for the forces acting on the mass itself.
everything.
Not any forces that are acting on different objects, those are completely different equations.
So it would be normal force minus W cosine
Theta
theta equals
was what?
MA. Yes. No, nothing.
And zero. Because you only have acceleration going in one direction.
That's why we choose our coordinates